the result of this. So what we have done is we had our order detail which had these values, and what we have done is we have said length minus 1 colon length. So you have taken these two elements and you have assigned that to your V1. Similarly, we can do length minus 1 and 2 elements. So I can do this, and now let's look at the value of V2. So this shows me the value where you are taking length minus 1 and then you are taking it till the second position of the index element, which is 20. So you are getting in the values here. So you get your 50, NA, 30 and 20 because you started with length minus 2 and up till the second index position. Similarly, we can use the length and we can take it from this element, and let's look at the value of V3. So that shows me that I'm doing some slicing, or I'm getting subset of my vector. So similarly, you can also do this one. So V4, and let's do this, and then let's look at the value of V4. So it gives me the values based on our subsetting or slicing. Now you can extract all the values below 30, and this is where you are doing a comparison. So you will take your vector and then you would want to compare each value if it is less than 30, and you would want to take all the values here. So it gives me the logicals or the response for all the values which are lesser than 30. What we can do is we can also use the square brackets and do this. This will show me the actual values. Here we were just getting the logicals, but here we are getting the values. Now to omit NA value from the vector, we can use NA.omit, and this one will help me in getting rid of the NA values. Plus I'm also checking the values if they are less than 30, and then I am basically doing using this NA.omit. So you can do something like this. You can look at the values. What you can also do is you can find the order details that are multiples of 3, and here we would want to use modulus, and we would want to find out if the remainder is 0, then I'm getting the numbers which are divisible or multiples of 3. So let's do this, and it gives me again the logical values of all the values which are divisible by 3, giving us a remainder of 0. Or if you would want to look at the values, then you can say order detail, open up a square bracket, and then pass in your condition. Now we can then omit NA from this one, and then we can look at the values. So this is a simple way where you are subsetting a vector or extracting the values which you are interested in, which might be one of the requirements of your data wrangling or data manipulation or just data extraction. Now I can also use a sum function. Now if we do this, it returns NA because there is already a missing value and you cannot do a sum on the values. Now what I can do is I can do a NA.rm to remove the NA values. So I can do a sum on order detail where I intend to add up all the values. But what I also want to do is I want to remove the NA value. So I'm giving it a value as true. And then if I do it, it gives me the sum of all the values. So similarly, you can do a mean, you can do a maximum, you can find out the minimum value, standard deviation, or even square root. Now these are some simple operations what we are doing on vector, where we are interested in extracting some specific values. Now let's look at matrix, which we have also discussed, and matrix is also one way where you can use the matrix function to create a matrix which is multidimensional. So for example, if I do this and if I look at the value of V, I get a matrix which starts with the value of 20, ends with 30, and at any point of time you can convert this to matrix. So first we created a vector, and now I'll create a matrix out of it, wherein I am seeing the row numbers, I'm seeing the column number, and I'm seeing the values in that particular column. So you have already done that. Now let's take it to the next level. So let's create a matrix wherein we are using the matrix function, we will say 0, 3, 3, and now let's look what it has done. So you have created a matrix which is of 3 columns and 3 rows, and by default the row number and column numbers have been assigned to them. We can also create a matrix by passing in values. So we can say 1 colon 9 and then give the dimensions, that is number of columns is 3, number of rows is 3. And if I look at the matrix, now I have passed in the values to my matrix. So sometimes you may want to arrange the data in a matrix for particular kind of calculations. You can also use n row and by row. So you can say how many number of rows you would want, and you would want to assign the data row wise. So when we are doing this, now if you notice the difference between the previous one where we just gave the values and we said 3 rows and 3 columns, so it was doing it column wise, so 1 2 3 4 5 6 7 8 9, but here we said by row is true, so it has arranged the values in a row wise fashion. So it goes 1 2 3 4 5 6 and 7 8 9. Similarly, I could have just done this by giving the dimension and selecting by row, and if I do this, it is still doing the same thing. Now what we can also do is we can create matrix using vectors. So here let's create a vector stock 1 and then stock 2. Now we would want to merge both the vectors, so you can always do a C function and then create a new vector, that is stocks, which is a merged result of stock 1 and stock 2. And let's look at the result. So that's my stocks, that's a vector. And now what I would want to do is I would want to create a matrix using this stocks. So I'm giving it a name, that is stock.matrix. I'm using the matrix function wherein I will pass my vector. I will say by row. So I want the values to be arranged row wise, and I'm also selecting the number of rows. So if you look at this one, so the values which we had in our stock, which was all the values, have now been arranged row wise and in 2 rows. So it starts with 450, 51, 52, 45, and 68. That's my first row. And the rest 5 values are arranged in the second row. So one of the main requirements is instead of going for default column names and default row names, we can give specific names to our columns and rows to make more sense to the data. How do we do that? So we can basically say days. So this is a vector which we are creating. And then what we want to do is we want to create a new variable, which is stock 1 and stock 2. Now this is for my columns and this will be for my rows. Now how do we assign that? So we can say column names, and this is where I will say on my stock.matrix I will assign days, which has 5 values, and that will become my column names. And similarly, using row names function, I can basically assign row names to my matrix. So if I look at my matrix now, it shows me the column names and row names which we have assigned or which we have passed to our matrix. Now there are different functions which are associated with the matrix, and let's look at some examples. So these are some simple basic examples. Now if I say let me find out the number of rows, and that gives me the number of rows or number of columns, or get a dimension, that is the number of rows and columns of your matrix. Now we might be just interested in getting the row names or column names or even the dimension names, which basically will give me returns the row and column names. So in this way you can use these simple functions which are associated with matrix to extract information about your matrix or data which has been transformed into matrix to pull out some information about that. One of the requirements which data scientist or data analyst might face is carrying out arithmetic operations on your matrix. Now what we can do is we can create a matrix which takes values 1 to 50. We want to arrange it by rows, and we will say number of rows is 5. So that's my values starting from 1. Now I can do a addition here by just doing a 5 plus mat 1, And if you notice, number 5 as a scalar value has been added to every element of the matrix. Similarly, you can do a multiplication, you can do a division, you can basically return the quotient if you would want to do that, or go for exponential values. So you can perform simple arithmetic operations for every element of the matrix. And what if you want to have arithmetic operations done on multiple matrix? So let's create mat1 plus mat1, and we get a total where every element is added to every element. You can do a subtraction, you can do a multiplication, and you can get the value. So this might be also very useful when you're working on multi-dimensional data. You can also do some more operations on matrix, such as returns the sum for each column. Say you are doing a summation, or at a row level, or you want to do a mean for every row, you can do that by using these simple functions. Now you can add rows and columns to a matrix using rbind and cbind functions. So rbind is for row bind and cbind is for column bind. But for that, we have to first create a vector. So let me create a vector of same length, which will then be added to every, or added as a row to my existing matrix. Now my matrix has 5 columns. So let's create a vector with 5 elements. And then I can basically add this as a row to my existing matrix by doing this. And now if I look at my values, I will see the new values as the third row. And if you also see, the variable name becomes the row name, and we have added a row to our matrix. Now similarly, I can find out row means, that is, we have seen earlier, by calculating the mean or average. So I can do that, and I can find out the value of average. Now what I can do is, I have got the average for every column, and what we can do is we can basically do a column bind by using a cbind function. And I will say I'm going to take the total stock, which has 3 rows, and then get the average. And now let's look at the total stock, which shows me the average value, which is the new column which has been added to the matrix. So these are some very simple operations which you can do, but that gives you good insight in what can be done at a matrix level where your data is arranged in multi dimensions. Now, how do we do a selection and indexing in matrix? So in vectors, we were using either names, or we were using positions, or we were using indexing. Now here, let's create a matrix called student, and we are using the matrix function. But within the matrix function, we are using the C function to create a vector, which will pass in all the values, which also has NA values. If you closely notice, we will split these values into number of rows is 4. So that means the number of values in this vector should be a multiple of 4. I'm saying columns is 4, and I would want to arrange this data row wise. So I've done that. And if you would want to get the dimensions out of this, so I can do a dim names. So what I'm doing here is, on my student, I'm assigning a list which will basically have these names which are basically assigned. And now if you look at your student, it basically shows me the values which were first applied to the row names, that is John, Matthew, Sam, and Alice. And then you have one more vector which goes as the column names for the values. So you have not only created a matrix by using a vector, by defining your dimensions, that is number of rows and columns, you have arranged the data in a row order. And what you have also done is, using a list function, you have passed in the values which will be applied as row names and column names to your matrix. Now, how do we extract particular columns here? So we can take our matrix and we can just say comma 1, and that basically gives me the values for John, Matthew, Sam, and Alice. And what we are looking at is the first column. Now I can also say from first column onwards, I would want to look at how many columns. So I can do this. And now here I'm selecting first and second column. I can also be using a vector function here, and that also does the same thing where I'm saying 1, 3, and I'm getting the values from first and second column. So third is not included here. Now, if you would want to do row wise, then you have to give the row position first. So if I do a student 1, that gives me the row values. And this is giving me values for my student, which we are seeing here. So for John, we have 20, 30, NA, and 70. And that's what we get here when you do a row wise operation. You can also do a row wise and how many rows do you want. You can use the vector function to do that. You can also select or slice out a value where you are getting an intersection of row 2 and column 2, and then you can also start from a particular position and then onwards get your rows. So these are different ways in which you are slicing the values from your matrix by columns or by rows. So at this point of time, let me just type in student here, and let's look at the value of student. And then here we are interested in 3 colon 4 and then 2 colon 3. So what does that give me? So you are looking at third to fourth row. So you're looking at Sam and Alice, and then you are looking at columns 2 and 3. So that basically gives you your 26, 32, 24, and A. So first is you're giving your row positions or how many rows you want, and then you're giving your column. So similarly, you can do this. You can say from row number 2 to 4, and then column wise, you can say 1 to 3. So if we do this, so this tells me 2 columns, which is first and second, and it shows me rows, which is from second to fourth. So in this way, we can extract data based on rows and columns. Now, if we would be interested in finding out a specific value, so for example, if I again bring up student, this is my student, and what I would be interested in is getting the value of John and for specific subjects. So might be we are looking for 2 colon 3. Now if I do this, it shows me for John, and what we are interested in is 2 colon 3. So that gives me the value for chemistry and biology. So you are giving the columns. So row wise, you have already specified the name, and that basically selects the particular row. I could have given a number and chosen which row or which rows we would want to pull out the values. Now, if I would want to find out the value for John and Sam, now in that case, I could use indexing or positioning, but that has to be continuous. But here you're talking about John and Sam, which has Matthew in between. So we will basically we will get the values for John and Sam, and then we will look at the value for. Now that is basically giving me the values in the fourth column, which is 70 and 75. Similarly, if you go further, you can look at maths and bio score of Sam and Alice. So you will give your row names, that is Sam and Alice, and then you would want the values for maths and bio. So that is basically your third and fourth column, and we can do that by looking at the values. How do you find out an average? Well, that's pretty simple. You can use the mean function on student. You will select your row name, that is John. You also want to get rid of NA values, otherwise that will give a problem. So you get rid of that by saying NA.rm equals true, and then you get the average score of John. Now, how do I do further computation? That is, if I want to find out the average and total score of all students. So in this case, I can apply, or I can use an apply function. Here, I'm saying I'm working on student, and we would want to give the row number, that is 1, and we want to also give the column. So I want to find out mean. I want to remove or get rid of the NA values. And now if I look at help apply, it tells me how does the apply function works over array margins. So I will do an apply function on student where I would want to select the first row. I would say I want the sum and I want to get rid of the NA values. So this gives me the sum for each student. And here we are getting a mean value, which was for each student. So what we are doing here is, for example, let's look at student again, just so that we avoid confusion. So we have student, and then we have physics, chemistry, bio, maths, and I have said row 1. So basically what we want is, for John, we want the total. And what we can do here is we can say 20 plus 30, avoiding NA, and then 70, that gives me 120. Then you look at Matthew. So this is again doing a totaling. There is no NA value. And you look at the value, right? So when we have chosen apply function, we have worked on student. Now here we are interested in the values, that is sum of all the values for this particular row. I'm saying take care of NA and then give me a sum. Similarly, you did a mean, and that was giving you a mean for each student. So these are some simple operations. Now what we can also do is we can basically create a vector called passing score. And what we would want to do is we want to get the values or find in how many subjects Alice has passed. How do we do that? We will have to compare Alice score, which should be greater than or equal to the passing score. So what we can do is we can create a variable here, pass. Now I'm saying student, I would be interested in the values for Alice. So I've mentioned that row name here. I'm then comparing it with passing score, which we have created here, and that will give me the values wherever Alice has passed in a particular subject. Now I can obviously get rid of the NA values and then look at this, which basically tells me there was one subject in which Alice passed and rest were either false or NA. Now same thing we can do for Sam. So Sam is here, and what we want to do is we want to look at the values here. So we will say let's do the same thing for Sam and find out the comparison with passing score and get rid of NA values. So you are basically extracting values. So these are some easier operations and usage of functions on your matrices, which are filled in with values at row level and column level. And then you can apply one of these functions or multiple functions to basically extract value, which makes more meaning. So that's with your matrix. Now let's also look at data frames. Now data frames, as we know, is basically data which has been ordered in rows and columns, wherein we can assign row names, we can assign column names, we can do some operations on data frames. So let's look at example. So if I do a data here, so that gets me some sample data sets or functions what we have here. So let's do, once we have our data here, so it says use data package, and then you can get list all the data sets in available packages, and you can basically look at all the R data sets which we are seeing here. It has opened up. So I would be interested in getting the air passengers data. So I'm going to pass that in the data function. And then if I do a head to see the initial data from air passengers, it shows me the values what we have. Similarly, we can do that on iris data set and look at the head values. I can do a view to look at specific values in a tabular format if that makes more meaning and that makes it easy for analysis. Now I can do a view on state X77, and that basically shows me the population and income and all this for different US states. So these are some different data sets what we have. You can do a view on them to basically understand the data or look in a more readable format. You can just do a tail to get some end data. So head and tail functions just give you the top 6 entries or basically your entries from that particular data set. Now the question is, how do we work on this data? So I can get a statistical summary. So I have the iris data set, which we had here. So if I do a head, it shows me iris data set. This is a popular data set which shows the petal length, sepal length of particular flowers and the species, what is the length, what is the width, and what species does that flower belongs to. Okay, now here we can get a summary, that is statistical summary of a data set, which gives me mean, first quartile, median, mean, third quartile, and maximum values. It basically shows you the count of the entries for each species, what we have under the species column. Now what I can do is I can check the structure of this data set using str. I can create a data frame now of this data using the data.frame function. So for that, we need to also have, say for example, if we would want to create a data frame, let's see how do we do that. So first we create a vector of days, we can create a vector of temperatures and rain, and then we want to create a data frame out of this. So I use the data.frame option. I pass in my days, temp, and rain as the vectors. And now if you look at the data frame, you basically see that I have my days, my temp, and rain. So those were the variables, those were the vector names, and those have become the column names. Row names are auto assigned, and basically we are seeing the values which have been passed in my data frame. Now I can do a summary on this to basically look at what is the length or how many values we have in data frame, what is the class of elements, so that is character. You are looking at your values or summary, which gives you mean, first quartile, median, mean, and so on. And then it also shows you the complete data on rain. What is the mode here? How many false or how many true values we have. You can also look at the structure of this data frame by doing a str, which gives me how many objects we have, how many variables we have, what are the different variables, so that is days, temperature, and rain, and the values for those. For days, if you notice, it is of the type character, temperature is numeric, rain is logical. Now, how do we do data frame indexing? So like your matrix, which basically has rows and columns and in multi dimensions, similarly in data frames also you have indexing. So you can do a data frame. So I could just extract the first row by doing this, and that basically gives me the value. So you can always compare it by just typing a df. So that's my data frame. And now let's look at the values. Extract the first row, and that shows me Monday 25.6, rain value is true. Now I can also do it column wise. So for example, I could do it in this way. So here what I'm doing is I'm doing extracting the second row from this one. So it tells me 25.6, 30.1, 40.0, 37.3. So you have extracted the values for the column, right? So I would not say extract the second row, you would say extract the second column. Okay, so this one should be second column. Yeah. Now selecting using column names, so that's the easiest way to extract the values for a particular column. So I can just do this. Instead of giving the position of the column or the column number, I'll give the column name, and that gives me all the values of temperature. And if I do this where I'm saying 2:4 and then I'm giving the columns, so it gets me the second, third, and fourth rows for day and temperature. And we are looking at the values. So you have given your row names and then you have selected your columns. You can also do a $sign if you would want all the values of a particular column. So I can just do a df $days or df $rain, and it shows me the values from my data frame. Now, one more way of doing that is using your bracket notation to return a data frame format of same information. So if you want the resultant data in a data frame format, you can just do a df rain or df temperature, and that is basically giving a data frame. So if I had assigned this to a value And if I had look at the type of this, that would be data frame. Now, one of the things which we also require is filtering data frames using a subset function. So that is subsetting the information from a data frame. So we know we have our data frame. Let's look at our data frame again. So that just reminds of what data values we have. And here, let's get a subset out of it using the subset function. So I'm passing in my data frame. I am saying I would be interested in the rain column. So I'm giving subset rain column and wherever the values are true. So returns all the columns where it has rained. Similarly, I can do a subsetting by giving a value for temperature wherever the value is greater than 25, and that shows me the value. So this is where you are filtering the data in data frames using a subset function to which you have to provide a column name and then giving a condition. Now, one more important thing which might be required is sorting your data frame using order function. So I can create a variable by name sorted.temp. I want to do a ordering of data frame, and here I'm doing a ordering based on temp. And now if I look at the value, or I can create this in an ascending order. So let's look at the values. And now if I look at my data frame, it just gives me the order or the ranking for the particular values. So we have discussed this in other section also. So what I can do is I can return all the columns with temperature sorted in a descending order. So right now what we were seeing was we were seeing in an ascending order, but what we can do is we can do that in a descending order. So here I'm creating a variable descending.temp. I'm doing a ordering, but when I'm doing a ordering, I'm using the minus symbol. And this one, if you would look at in the form of a data frame, it shows me the values which are ordered in a descending order based on the temperature column. Now, another way of sorting is by using a particular column. So what I can do is I can sort, I can do a order, and then I can choose the column based on which I would want to order it. And then if you would want to get the values of this, so it tells me the values have been ordered based on temp. So this can be very useful when you would want to sort the data or order it in a particular way to basically understand your data or to make more meaning out of it, right? Similarly, one more requirement might be merging your data frames. So here I'm creating a data frame. So I'm saying authors and I'm using data.frame function. And what we are doing is instead of creating three vectors, I am basically doing that within my data frame function. So let's do that. And now what we can do is at this point of time, I can check what my authors look like. So this is my authors. Now here, if you see, we have the vector Turkey, Venables, Tierney, Ripley, and McNeil. So that becomes my first column, which is surname. Then you have your nationality, and then you have deceased, where you have also repeated the values 4 times, right? So that's something new which you might be seeing. So you are creating a vector where you are passing in a value, and for other set of values, you are basically using a repetitive function. Now, similarly, we can create a data frame called books, and this one is where I am having name column, title, and then I have other dot author, and you are passing in the values. So at this point of time, if you would want to look at your books, it would look something like this. So you have given a name. Now just closely look at the data frame function. So here you're using the names, you have the titles, whatever values you are passed in. Always remember, when you have multiple vectors, they are ending with a comma, right? So do not forget that. And then you have other dot author. So that's the name of the column. And you are passing in the values where you have also passed some NA values. And at this point of time, you can look at authors. This is your books. And our intention will be to merge these data frames. So that's what we would want to do. Might be we are interested in getting the data together. So what I'm doing here is I'm saying M1, Now I want to use the merge function. I pass in my data frames, that is authors and books. So if we closely look at authors, it has 3 columns and 5 rows. And here you have 3 columns and we have 7 rows. So we would want to do a merge. So we'll say authors books and we will say by dot x. So this is where I'm choosing which is the column based on which I would want to merge. So I have by dot x, which is surname, and by dot y, which is name. So we would want to merge the data where we are giving a condition based on values in surname and name. So you see there is Turkey here, there is Turkey here. We have Venables, we have Tierney, we have this one, we have Ripley, which we have here multiple entries, and then you have McNeil. Now we don't have R core, which is there in your author. So let's see what happens when we do a merging here. Okay, and now we see the result of this merge where it has taken all the values from both the data frames. So you have surname, nationality, deceased, you get the title, you get the other dot author, which you are getting in from your books, and the name column is avoided, right? Because we are doing the merging based on surname, and but y dot name is name, so we don't see the name column. But what we are seeing here is the values which have been merged, and then you can compare. So for example, let's do a random check. So if I look at McNeil, that's the surname, or here it was name. So you have McNeil, you have a nationality which comes from the first data frame, deceased from the first data frame, then you have your interactive data analysis, and then you look at title.author. What you don't look at in the merge is this R core, because this does not have any value in your author's data frame. So you can do a merging of your data frames using the merge function. So please try it out, and you can create different data frames and try to use this. Similarly, you can manipulate a data frame. So for example, here we are creating one more data frame called sales report, which is data.frame. You are giving an ID, product has some values, unit price is where you are getting the values as integer and quantity as integer. So now if I look at my sales report, this is the values which I have. Let's spend a couple of seconds to look at this value. So ID value is 101 to 1010. Product is A, B, so that is automatically assigned. Unit price is starting where you say 101, 140, 184, right? So we are using a as dot integer, we are converting it into integer, and basically we are assigning these values here for your unit price. And similarly for quantity, we are assigning the values by doing a as dot integer and then just doing a run if. Now once we have done that, we have created a data frame. Now how do you transpose? What do you mean by transpose? So transpose is when you are changing your accesses. So if I do a transpose on sales report, and if I want to do a view, so you will see the positions which have changed. So you have all these values. So my row names or row whatever values become the column headings, and basically your column headings becomes your row names. So that is what you're achieving by doing a transpose. You can do a head to look at some initial values. You can do a sorting of this data frame by using the order function, and you can choose the column and also the order if you would want to have it in ascending or descending, or basically increasing or decreasing values. You can also choose a particular column, like we are choosing product as a column, and I would want to take the values of sales report in a descending order, that is unit price, and we can just do ordering of data frames or sorting the values in data frame. So this is pretty easy. Please spend some time in practicing these things, taking these examples, and you will learn more about these functions. You can always try creating an example at your end, and you can try to look into these. Now, what about subsetting the data frame? So when you're saying subsetting the data frame, let's do a subset function like what we used earlier. I will say subset.product A. I'm using the subset function, and here I will get the subset based on the product value being A. Let's look at this, and this shows me only the values where product value matches A. Now extract the rows for which product is A, and unit price is 150. So you are still doing a subsetting, you are still passing your data frame. Here you will give the product is A, which will tell basically the values for product and unit price greater than 50. So you're giving some conditions and look at the values. Now, if you're only interested in particular columns, so if I say only the first and the fourth column product is A and unit price is 150. So you have to still use your subset function, pass in your data frame, product will be given as A, and unit price should be greater than 150. But what I'm interested in is the values from the first and the fourth column. And now if you see, it shows me the values for my fourth column. What we can also do is we can create two subsets. So set A from data frame, where we take the product as being A, other one is being B, and then we can look at the values. So this is just A, this is just B, and what we can do is we can combine them or we can merge them using column bind. So when I say column bind and I'm saying set A, set B, so it is basically going to stack the data frames column wise, and if you do R bind, it is going to stack the data frames row wise. So we can either use column or we can do a row wise. So this is in one way where you can merge. The previous example where we saw merging was based on a particular condition which is met based on some columns which might have similar values, right? And this is where you are straight away merging the data frame using column bind and C bind. So if you compare this with the other merge operation, what we saw here, this was where you are comparing the values of first data frame and second data frame and then merging. But here we have just used column bind and row bind, so we are not merging on a particular condition, we are just stacking them either column wise or row wise. Now what we can also look at is doing some aggregate operations. This is going deeper into data frames. So when you use an aggregate function, you are passing in your data frame, you are choosing the quantity column, and then you are basically using the list function. So list function is going to work on your data frame on the product column. So product column for your sales report. So at this point of time, let's look at sales report. And let's look at the value here. So this is my sales report. And what we want to do is we want to aggregate the values on quantity column. But for that, I will say, I will just take the product columns and I will get a sum wherein I'm ignoring the NA values. Let's look at this, and that gives me an aggregation value. So remember, aggregate function is doing a summing up. Now here we are doing a summing up on your product, that is sales report product column is what we have. So you are kind of grouping by based on product. So we have two products here, A and B. Now what we also want to do is we want to take the quantity column. So that's why we have given that first. And what we are doing is we are doing a summing up. So we are summing up all the values for A and all the values for B. And we are seeing that here, if there are any NA values, we are ignoring it. So these are some basic operations on data frames or matrices, subsetting them, extracting useful information, using some inbuilt functions to do transformation or computation and extracting some values. Now, similarly, we can also work on lists. Now that we have looked at data frames, matrices, vectors, let's also look at one more structure and how we work in R when we have to work on lists. So list is basically a structure here, and what we are doing is we are creating a list by using the list function, and here I am passing in three vectors you see here. Now C function is being used. Now in vector we know that all the elements are of the same type. Now let's create a list wherein we see three vectors which are of three different types or objects of three different types. So let's create this list. And now let's look at our list. So it basically has elements wherein you have values of different types. We can create a different list which can also have sequence elements, that is 1 to 10, a matrix which is of 3 dimensions, and then also passing a list. So this is also one way of creating a list. Let's look at list 2. And if we look at the values here, list 2 basically has a vector which has values 1 to 10. It has a matrix of 3 into 3. It has a list which has values A having 10 and B having 20. So this is how you can create a list which can have objects of different types. So we can also use recursive variable, a variable that can store value of its own type. So for that, you have to use a recursive function, something like this. So I'm saying is recursive and then do it on your list, and we can check if the list basically has a variable that can store values of its own type. Now, one of the main requirements when you're working with lists is indexing. So I have created a list, and here I can access these elements by using an index. So if I do this, this shows me the matrix. What I could have also done is using the dollar symbol and then choosing particular element of the list by doing a mat, which is the name given to our matrix, or by choosing a name that is vector. So you can access the elements using indexing or dollar notation or giving the name of a particular element. Now I can also work on list and I can get the third element's second value. So we can do that, and that shows me 20, or you could have done by giving the value 3, that is the third element, and within that you are looking for second element. So I can get the length of the list, I can get the class of the list, which shows me it is type list. And what I can also do is I can convert vectors into list. So here we are creating a variable price, which is being assigned a vector which has 10, 20, and 30. And now what I want to do is I would want to convert this vector into list. And for that, I'm using the list function. So I am creating a variable called price list, and then I'm saying as dot list. So that's going to convert my vector into list. And now let's look at price list, which shows me a list, or you can look at price, which is a vector. So that's when you're converting your vector into list. Now, how do you convert your list into vector? And that also can be done by doing a unlist function. So I can basically work on price list wherein we converted vector to list, and I can just do a unlist on that, which will convert my list into a vector, looking at the values of the vector. Now, sometimes we may want to get the dimensions. So we can use the dimension function to convert the vectors to a matrix so that it can have multiple dimensions. So here we create a vector which has 4 values, and then I'm going to give a dimension to this so that it is converted from vector into matrix by giving dimensions 2, 2. And now if you look at price 1, it has basically changed into rows and columns of 2 into 2 dimensions. So these are some simple examples of working with list. Now, when you talk about basic data type functions, we have seen how you use the assignment operator, how you get the data type of a particular variable or the class to which it belongs. I can assign different values such as 10.5. So the previous one was showing me the value numeric, and now what we would want to do is we want to assign a value 10.5. Look at the class of it. It says numeric. Type of it shows double. So by default, it belongs to the double class. Now I can check if the values in N1 are numeric, and that shows me true. And similarly for N2, and that shows me 2. So you're using the numeric function, which returns true if the given value is numeric. Similarly, we can have integer assigned to a particular variable. And for that, either I can do as.integer or I can assign a value with capital L. So I can do this and look at the value of I1, similarly I2, and look at the values. And if I would want to check if that is an integer, let's look at the values of I2, which was an integer, I1, which was an integer, and I3, which is an integer. So here we have assigned integer values to a particular variable. Now all integers are numeric, but all numerics are not integers. So let's check that. So if I do a is numeric on I1, which was assigned as dot integer 10, that shows me true. If I say is dot integer on I1, so was that an integer? And if I look at the value, it shows me true. Now let's look at the character values. So if we say C1, C2, and look at the class of this, it shows me it is of character type. Similarly on C2, and you can always validate that by using the character function. You can also use some inbuilt functions such as converting to an uppercase or getting a substring from the starting till the position what you would want the elements. I can do a paste function, which basically will give me the data combined, or you can say concatenated. You can also use a paste 0, which we know will get rid of the space and it just concatenates them without a space. I can also use a specific separator, which we have seen examples, and we can do that. And what we can also do is we can replace set of characters. So here I'm saying substitute, and then if I look at the values, it has basically replaced Rob with Senna. And let's look at the length of it or number of characters in this. So these are some basic operations what you're doing on matrices, on your data frames, on your lists, and also on your variables, where either you are assigning them values of a particular type or you are changing the data types. You can also go for coercion. In case of vectors, we have seen that, where if you are passing in values of different types, that's coerced into same types. So later we can learn more on functions and flow control and how that is handled in R. Let's learn how R can be used to take care of flow control. That is, if I would want to have a if else condition, and if what I would want to compute, or if I would want to check some values, how R can be used. So here, if statement consists of a Boolean expression which is followed by one or more statements. So we can just say if, we can pass in a Boolean expression where we would want to compare particular value or we would want to check a particular value, and then whatever is passed in the statement will get executed. So what we can do is here we can use assignment operator. I can pass a value to X. Now we can always do a type of, and that can tell me that X is basically an integer. And now I can use my if, where I can say is dot, and then I can choose integer, and I would want to check the value of X. If that is an integer, then I will just use brackets and I'll pass a statement here. So let me say print, and let's say X is an integer, and we can execute this, and this tells me that the Boolean value is true. Now if, for example, we would have done something else, or say for example, instead of integer, if I had used let's say character for that matter, and we can check the value and we can do this. So here we will check the values, and it says there is an error with the bracket, and let's check this one. So if X, because we missed a bracket here, so let's do that one and then try this, and it doesn't show me any result. So how could we handle something like this if the Boolean expression does not match to true? And in that case we can always go for else statement. So we can check for a value, So if the Boolean expression is true, statement will be executed, and if it is false, then next statement will be executed. So we could have done the same thing here, where I said print x is an integer, which we know is not true. And what I could do is I can here after this one say else, and then I can open up one more bracket, and then I can say print, and I will say x is not a character. And now we know that x is not a character. So this is a simple way where you can use if else, and you can control the flow by passing in the conditions. Now that's when you're using if else statements. Now, what about while loop? So that also can be useful when you're programming in R. So an else statement is executed when the condition in the if statement results to false. So that basically means what we can do here is let's pass in a word or a set of words like this. For example, let's say v, and then we use C function to create a vector, for example, and then I can just say hello world. And if you look at v, you can look at the class of v, it's of characters. And if you look at type of v, it is having the objects or elements as character. Now what we can do is we can basically then say count, and let's assign this a value 2. Now what we would want to check is the count of elements in our v equals to 2. So what I can do is while my count is less than say 5. Now I'm saying I would want to do something while the count is less than 5. So we have already given a value to count as 2. And now what I can do is here I can open up a bracket, I can say print, and then pass the value of v. And then what we do is not only this, we will also increment the value of count, and we will say count plus 1. And here it gives me error, probably because we have missed a bracket. So let's see what we are missing out here. So let's just check this one again. So here it is. We have created v, which has 2 elements of the type character. And then what we do is we assign count a value of 2. And we would want to check while the count value is less than 5, we would want to print the value of v. So what we are doing here is we are saying while, then you pass in an expression which will check the value of count. We do a print, and then we increment the value of count. Now this is a simple example where you are using while to basically test an expression, and while that expression is true, you would be doing something whatever is passed within your brackets. Now we could also be going for loop. Now for loop is basically used to iterate over a list of elements or a range of numbers. So for example, if I have a vector like fruit which has some values, I could just say for I in fruit, I would want to print something. So let's try this also as an example to test our for loop. Now we can just say names, and we can basically then assign values to this. So let's say VJ, AJ, DJ, and let's say SJ, and let's create this. Let's look at the value of names. Now what I can do is I can use a for loop, and I can say for I in my names. So I will say for I in names. Now what do you want to do? So open up your brackets here, and then we would want to say print I, and then basically close the bracket. So you see, for every element in this vector, it is basically going to print the name one by one. So you're iterating through a set of objects by using a for loop. Now this is how we can work on for loop. So if else, while, and for loop can be very useful when you would want to iterate, or when you